Okay, today we're going to talk about something new called complex numbers. Pretty basic thing, just means that you have an imaginary number in your answer. An imaginary just represents when you have a negative radical. And this is specifically when you have those even indexes, so like 2 radical, maybe like -3. When you move the negative outside, it becomes an I to represent that negative underneath. And then you still have the radical 3. So it's just a coefficient. So in your homework, you're going to have some problems where you're just converting those negatives into i's. Remember, if it's an odd index, though, then the negative just stays negative outside. So with complex numbers, when you're writing the final answer, you do want it in standard form, which is the whole number plus the complex number, or minus the complex number. And if you have like 3i or 2i, you always want the I at the end. I only goes at the front if there's a radical. So if you had like 2i, it'd be written like that. So the steps are pretty easy. They're very similar to adding and subtracting polynomials, because I is almost exactly like an x or a y. So you're going to distribute any negatives. And I've still seen a few people making mistakes on those, so please double check your notes from Unit 1 if you need it. Then you're going to combine all the real numbers with other real numbers. Okay, so 2 plus 2 equals 4, that kind of thing. Imaginary numbers go with imaginary numbers, and just like we added like 2x plus 5x, we get 7x. Same thing, 2i plus 5i gets you 7i. So you're only adding the coefficients, the i's don't change. And then your final answer needs to be in that form, a plus bi. So number plus coefficient, imaginary. Okay, so the problems are very simple. It's just the concept of I that's weird. So here we're going to distribute the negative. So we're going to rewrite it as 8 minus 2i minus 4 plus 8i. This is the one I've seen a lot of people forget on the quizzes and tests. Okay, real numbers. We've got a real number here and here. So those are the ones that don't, these are the ones that don't have I on them. So we have 8 and -4, and that gets us 4. Imaginary numbers, those are the ones that have an I. So we've got -2i and plus 8i. And you have to keep the signs here. So -2i plus 8i. Add those together, we get 6, and the I is still there. So our final answer, we have the 4 plus 6i. So just because I wrote the I already on there does not mean you need to forget the I when you're writing your answer. Okay, problem number 2 is just a little bit longer. So again, distribute that negative first, and this one has another negative that needs to distribute. And then you're going to rewrite the answer. So go ahead and write that answer in. Okay, you're going to get 5 plus 7i plus 8 plus 5i. When you distribute the next one, plus 3 plus 5i. So I'm going to go ahead and highlight all of the ones that are real numbers. Oops. Real number, real number, real number. So we have 5, 8, and 3, all positives. Add those together, and we're going to get 16. I'm going to go ahead and highlight the imaginaries, so that's the ones with i's. And notice I'm doing the signs with them. We get 7i, 5i, and another 5i, and that gets us 17i. Go ahead and write your final answer in. Should get 16 plus 17i. That I goes very last. Okay, go ahead and try problem number 3 on your own. Remember to distribute this negative. Okay, you should get -6, take away 4i, take away 1, take away I. Go ahead and add any like terms, so real numbers together, imaginary numbers together. Okay, you should get -7, take away 5i. as your final answer. Okay, that was super easy. Homework should be super fast with that. Biggest concept is understanding what I is. Our next section, we're just going to multiply these. Now, the difference with multiplying is that you run into, when you have I times I, we get an I squared. That I squared, if you remember, I is a radical of a negative. So when you square that radical, you end up with just the -1. So we actually replace any I squareds we get. This shouldn't be in your final answer. So if you look right here, oops, I thought the highlighter was on. If you look right here, we have 4I squared, but the I squared becomes -1, and it's not adding, it's multiplying. So we get 4 times -1, which gets us that -4. Okay, just like in regular polynomials multiplied, when you see that something's squared, which I've still seen people do on the test, rewrite it as 2 of those. Okay? It's going to come up and come up and come up, and I've already seen most of you guys make that mistake on the test. So, again, squared means you have 2 of the whole parentheses. Okay, just like multiplying polynomials, we distribute that first term to the second polynomial. You get those answers. You do the same thing with the second term and then distributing to all those answers. And if there's a third term, you keep going. So you're going to have a line of answers like 5 take away 2I plus 3I plus 4I squared. You're going to replace the I squareds with a -1. And then you're going to get a couple whole number or real numbers and a couple imaginaries, so you're just going to add those like terms. So real numbers with real, imaginary with imaginary. Okay? If there's a third polynomial, so let's say we just did this part. Okay, so we multiplied these two, and we simplified and got an answer. We still have the third polynomial, you just distribute again. It just comes up a couple times. So let's try a practice problem. So problem number 1, go ahead and distribute that 5, and then distribute the -3i, and write that right below. Okay, you should get 35, take away 35i, take away 21i, plus 21i squared. Okay, go ahead and replace the I squareds, which is just that last term. So we have 35, take away 35i, take away 21i, plus 21 times -1, which is really -21. And add the like terms. So real numbers, go ahead and highlight and add together. So it's 35 and -21. And highlight the imaginaries. -35i, -21i. And our final answer. Real numbers first. So 14. And then imaginaries. -56i. Final answer. Super easy. You just have that one step of replacing the -i. Otherwise, it's just like a polynomial. Okay, look at number 2. Go ahead and rewrite this. You've got that squared. I need to see 2 parentheses. So you should have -4 plus I, -4 plus I. When you do this, it does not change the signs. It's just 2 of the same parentheses. Okay, distribute the -4 and distribute the I and write that answer on the next line. You should get 16 plus -4i plus -4i plus I squared. And rewrite that with the I squareds replaced. So we get 16 plus -4i and -4i and -1. There's no multiplying here because there's no coefficient. And add real numbers together and add imaginaries together. And write your final answer in standard form on the next line. should get 15, take away 8i. Box that, it's the final answer. Okay, one more practice problem. Go ahead and distribute -6 and distribute the 2i and write that final answer. Remember to show all your work. And go ahead and replace I squareds and simplify. So you should get -24, take away 42i, plus 8i plus 14i squared. That becomes a 14 times -1, which is -14. So your final answer should be -38. Take away 34i. And that's it.